So we saw the idea of a top-down approach to solving this problem, which basically meant that we were going to start at the largest n value, then we were going to slowly decrement through, storing our results until we reach the end of our n values. And we saw that this worked pretty well. It made it so that we could actually solve larger cases, whereas our previous approach didn't work for that at all. In this video, I'm going to show you what I think is usually the best approach to dynamic programming. It's not always going to work, but when it does, it's probably the favorable approach for most people, which is a bottom-up approach, or sometimes referred to as tabulation. And the idea here is that we're going to start at the lower side. So we're going to start at, in this case, 0, and we're going to increment our way until we reach n, remembering the values that we've seen along the way. This allows us to create a fully iterative approach, and it will probably be our most efficient approach for this particular problem. So I'm going to create a new function. I'm going to call it climbStairsTab. I'm going to give it a value n. And all we really do here is we just say, well, if n equals 0 or n equals 1, we already know that we're returning 1. Otherwise, I'm going to create an array. And that array is going to have enough entries to store everything that we're going to see. The reason why I do this is because I don't want to do appends. Appends could have a bad time complexity, so I want to try to avoid that. So I'm just going to initialize my array to have enough space to work with the data that I need to work with. I'm then going to initialize the solutions for 0 and 1. So the solution at 0 and the solution at 1 are both 1. Then what I'm going to say is for I in range of 2 to n plus 1, which will be all the possible values that we want to iterate, I'm going to store the solution at I, which will be equal to dp at I minus 1 plus dp at I minus 2. Now notice how this is going to work, right? When we first start off, we initialize 0 and 1 to be 1, since no matter what, if we have 0 or 1, it will only be one possible combination of steps that we can take, right? From here, once we start at 2, basically it's going to take the solution at 0 and 1, right? Or 0 and 1 in this case, right? It's going to store it inside of the result of 2. Then at 3, it will take that previous result 2, add it to the result at 1, store it as 3. At 4, we take the previous result of 3, we add it to 2, and we just continue this on until we've iterated through all of our results. We go to n plus 1 because we want to do it up to 5. If we didn't do n plus 1, we'd end up at 4, right? So this gets us up to 5. Then we just return back the value at 5, and we're done. So do you see that this really is the same sort of approach to this result here? Basically, all we're doing is we're just getting the previous result and using it to calculate the new result, right? This right here is a really great time complexity. It's ON, right? It's linear time. We just have one loop. Everything else is constant time lookups or sets inside of our array. This is definitely the preferred solution for this kind of problem. It's very simple in terms of time complexity. It's a fairly simple iteration, and it allows us to be able to solve this problem quite quickly. So like I said, this is a bottom-up solution to dynamic programming. In every case where I have this option, I'm going to use this option because it's iterative and it's typically going to be mainly the most efficient option. Unless this solution doesn't work at all, if it has to be recursive, then we can go to our memoization-based approach, but usually this is really the main preferred approach that we have. So with this, you've seen the main ways that we could approach these kinds of problems. We saw divide and conquer, and we saw how that wasn't really working too well. We saw our top-down approach, which is a pretty good approach, but it's still a little bit slower than our bottom-up approach, which is the main one that we want to use, which gives us a linear time complexity overall. So with that, you now have a basic understanding of dynamic programming. We'll take a look at some more example problems to really solidify how this works. So thanks so much for watching. I'll see you in the next video.